Bismillahirrahmanirrahim. Respected Chair, dear colleagues and participants, Assalamu alaikum and good afternoon. I am Tariq Aziz from University of Agriculture Faisalabad and working with International Nitrogen Initiative and the United Nations Environment Program as a steering committee member for Global Partnership on Nutrient Management. I will be discussing the nitrogen paradox, feeding the world while fueling climate change. And I'm really thankful to the organizers for providing me this opportunity. So nitrogen, or reactive nitrogen, is essential for the very existence of life on Earth because it is a structural component of many of the biomolecules like protein, DNA, RNA, chlorophyll. So it has a significant role in food security, one of the biggest challenge. If we see on the right panel, there are graphs, and you can see that the nitrogen fertilizer or the nitrogen input in the soil has been increased significantly from 1950 onwards. And it has been well correlated with the food production. As nitrogen fertilizer use has been increased, there is a significant increase in the overall crop production, particularly in the cereals. On the same time, the nitrogen surplus has been increased. Surplus means the amount of nitrogen which we add in the soil, but it is not taken up by the plants. And resultantly, the global nitrogen use efficiency has been decreased. And it is very much relevant with the surplus. If surplus is increased, use efficiency is decreased, and vice versa. And you can see on the left side that the total nitrogen inputs in the system is more than 161 teragrams of nitrogen, and out of this 86 teragrams of nitrogen per year is the surplus. So nitrogen recovery efficiency is more or less 46%. So this is alarming, as well as it has a significant potential that we can improve the recovery efficiency. We can produce more by utilizing less. But this reduced use efficiency or increased use of nitrogen in the system, it has resulted in a number of ways, like it has deteriorated water quality, air quality. It has impacted on greenhouse gas balance and ecosystem, and of course, soil quality. And the nitrogen has already crossed the planetary boundary. So we need to address this challenge. And if you see on the crop sector, the use efficiency is seriously low in South Asia and in China and Sub-Saharan Africa. So we need to improve the use efficiency. And if we compare the three major countries in South Asia, very much evident that nitrogen use efficiency has been decreased from 1962 onwards. Except in Bangladesh, where after 1990 and 2000, there is a slight increase in use efficiency. And the global use efficiency in the world is less than 50%, but in the case of Pakistan, it's less than 30%. So the situation is demanding. And if you see the relative difference from the global means for the South Asia emissions of nitrogen oxides, ammonia, and nitrous oxide, there is a clear-cut indication that the South Asia is a global hotspot because the emissions are more than the global average. And particularly, nitrogen is relevant to the climate change. So I would discuss on the nitrous oxide, why mitigation of nitrous oxide matters. Because it is a super pollutant. It has 273 times higher global warming potential than carbon dioxide, and its lifespan is more than 100 years in the atmosphere. And it contributes to both climate change, ozone depletion, and agriculture sustainability. And if you see, the current nitrous oxide emissions are almost equal to sum of all other ozone depleting substances weighted by the ozone depletion potential. So there is huge opportunity as well as the challenge to reduce the nitrous oxide emissions. And if you see the two graphs, the above is from 1980 and the below one is representing 2020. You can see the clear cut. If you see on the South Asian region, the nitrous oxide emissions have been increased tremendously, and also from some part of the China as well. And in 2020, the global nitrous oxide source is about 28.3 million tons per year, of which 35% is due to human activities. So anthropogenic sources are significantly higher. And which sector is responsible for this increased nitrogen emissions, nitrous oxide emissions? From the left panel, you can clearly see that there is a line on top. This represents the agriculture, while all of the other sectors, they are quite less. So the major contribution towards nitrous oxide emission is from agriculture sector. And it is very much clear from the right panel that as fertilizers inputs have been increased from 1905, the global nitrous oxide concentration in the air has been increased significantly. And it has been increased from 281 parts per billion to 334 parts per billion from 1905 to 2021. So this is a great increase. So we need to work towards sustainable nitrogen management because it is linked with many of the sustainable development goals. And as we know that there is only about 3.5 years to the target here, that is 2030, we need to achieve. And if we are working towards sustainable nitrogen management, it means we can contribute to achieving these sustainable development goals. But having nitrogen waste, is it possible? There are science solutions like farm management solutions, genetic solutions, efficient fertilizer development, or precise use, and there's a need for education and awareness. But having nitrogen waste is more ambitious. It needs transformative change. It needs dynamic policies. Are these available? So we worked for the South Asia, and more than thousands were studied, and about 649 policies out of the South Asia were identified, which has direct or indirect link with the nitrogen. Of course, there are some policies which worked towards decreasing nitrogen, but some policies may increase. So all of the policies, they are fragmented in different sectors because nitrogen is linked with many sectors. It's a cross-cutting problem. So we need policies which are coherent, which are integrated with various sectors, that this cross-cutting problem can be addressed. So South Asia is, of course, the hotspot, but it's very active towards raising awareness, towards addressing this challenge. And we were successful in submitting and adoption of the two resolutions in the United Nations Environment Assembly, first one in 2019 and second one in 2022. And there were Colombo Declaration, there was Nitrogen for Net Zero COP26 event, there was side events in COP29, COP30, which were hosted by the Ministry of Climate Change in collaboration with University of Agriculture, Faisalabad. So we are working. And this was a publication from one of our projects, nitrogen mitigation. We collected the available measures, which have been proven by the science, which can reduce the nitrogen emissions, nitrogen leaching, and nitrogen, which can reduce the nitrogen surplus. So this is available online, free of cost. And if you see just the cost and benefit on implementation of the selected measures, the benefit cost is almost 10 times of the implementation cost. Of course, this is different in different regions and the different countries. But the takeaway message is some of the monetized human health, ecosystem health, climate, and the benefits are more than 10 times of the estimated gross on net agronomic implementation cost. If we spend one rupee on the any measure to reduce nitrogen emissions, the resultant benefit is more than 10 rupees. So fertilizer cost saving in high application rates and low nitrogen use efficiency, such as South Asia and China. And there are yield benefits such as Sub-Saharan Africa. And of course, the ecosystem benefits will be greatest where leaching losses of nitrogen are causing significant coastal eutrophication, such as in China, North America, and Europe. And the most important, mitigating nitrous oxide emission is essential for climate, food security, health, ecosystem, and biodiversity. So thank you for your patience, and my email is given for any comments, any questions, or any collaborations. Thank you very much.